Kato Engineering is a company that's been around for a long time. We make motors and generators from a size range of about, at our facility in Mankato, we manufacture down to the size of about 2 megawatts up to 15, 20, 30 megawatts. Kato Engineering is in what I consider a really unique business in that we have all these different aspects of physics that cause real-world problems. We've got vibration problems, we've got structural problems due to stress and strain, we've got heat transfer thermal problems, we've got fluid flow issues. A lot of the machines are cooled by a fluid, whether it be air or liquid. We've got electromagnetics issues. The heart of the machine is really functioning with electromagnetics. So from a simulation standpoint, it's a really unique industry in that we're interested in all of the different tools that are out there. And we have problems, real engineering problems related to all those different physics. Kato Engineering chose Ansys as a software partner really because of their level of complexity in terms of the ability to solve a lot of different problems in a lot of detail. I had some experience with other programs that are maybe what you'd call more beginning programs or less in-depth on particular issues, but the real thing that I find attractive with Ansys is the complexity and the level of detail that you can get into. We're using the Ansys software on a daily basis for a lot of different things. We're using it for rotor dynamics, which is an aspect of the machinery vibration modeling. We're using it to calculate stresses and strains in structural components in order to evaluate their structural integrity. We're using it for fluid dynamics to understand, when we have an air-cooled machine, how the air flows around the machine. We're using it for heat transfer when we have conduction through solids to try to understand. Every electrical machine that's built is basically limited by how hot it gets, so it's a huge part of the process for us. And we're also using Ansys for the actual electromagnetic, modeling those phenomena to understand how that machine's going to perform, what kind of power input requirements it's going to need. So we're really using all the different aspects of Ansys on a regular basis. The biggest advantage I would say that we get from running the simulation software is, and truly, and this would be in my opinion, is a more in-depth understanding of what's really happening. Beyond that, there's also the time advantage of the fact that we can run these simulations faster than you can run a test. And just the complexity advantage, we can analyze things that are more complex than, say, textbook calculations. But really the biggest advantage that I see is really the smarts we gain from running the simulations and the things we learn. It makes us smarter, it makes us more able to really understand what we know and what we don't know and what the difference is between the two. One of the advantages that we see with Ansys is not only the ability to dive into one set of physics, but also the ability to combine multiphysics. And for us, again, speaking in the terms of motors and generators, that's a really big asset because we really have problems related to all of them, and they're all part of these machines. The machine designs themselves the technology has been around for almost 100 years, but the problems, the day-to-day problems are very, very intertwined multiphysics, so Ansys brings that ability to bring it all together. With the Ansys tools, we are definitely able to design smarter products.